do with this talk, I want to celebrate that all of these whales that have come back. I want to also keep you on your toes, because when things tend to come back like that, a lot of times we start to perceive them as problems because we didn't remember when they were here before. And the other thing that I want to do is introduce this idea that the ecosystem is way more complex than we think about. And so when we think about one predator or one prey, we take away the complexity of the ecosystem, and then it's easier for us to think about removing something along the way. So there are numerous species of forage fish in the Salish Sea. I'm going to go over those. So this is a list that SeaDoc funded a few years ago. Ted Peach and Orr did. So we've got northern anchovy, we've got the herrings, the clupeids there, and we've got a whole bunch of different smelts. And that doesn't even account for things like juvenile rockfish that this common murre is eating. So there are a lot of fish that convert plankton into fat for top predators to eat. And I just want to give you one example. I know you want to hear about whales, but I'm going to talk about birds first. That the mix of all of these forage fish changes year by year. So we're going to use our friend the common murre. Common murres are amazing. Those wings are really designed to fly underwater, not above water. That's a bonus superpower. These birds can dive to almost 600 feet deep. And in the springtime, they lay one egg. It's actually a cool shape. It's pointed at one end and fat on the other end. They lay it on a cliff, and so if it rolls in a little circle like that. And then they go out and they spend the summertime feeding their young. And what you see here is a graph from 1996 to 2009. There were a couple dry years where there was no funding. I think you can see those, 2007, 2008. And what you see, the different colors are different forage fish. So you'll see, oh, one year, herring are very important and salients are not that important. And then another year, something else happens. 2006, the herring importance goes way up. And then look what happened in 2009. The whitebait smelt were very important for them to be able to feed their young. And we did a study, one of our postdocs, Nacho Vilches, published in Conservation Biology a few years ago, where we looked at 1/3 of the birds in the Salish Sea are listed as threatened or endangered. And when we did what's called a risk assessment to figure out why. What are the traits that would make you more likely to be endangered? If you're a diving bird that forages for small schooling forage fish, you're 18 times as likely to be in decline. So we don't have a bird problem, we have a fish problem around here. Okay, so we'll go back. First I want to talk about gray whales. Like I said, this is going to be a success story. So now we have about 18,000. We hunted these whales to almost nothing. And we removed them off of the U.S. Endangered Species Act in 1994, which was great. Now, within the Salish Sea, these whales migrate from Bering down to Baja, they give birth, and then they migrate back north again. What you see happens in the Salish Sea, starting right around the early 1990s, a couple of those whales come in on their northern migration. And then they'll feed here from about March till May, and then they'll leave again and they'll go back up to the Arctic and continue feeding. There's a small group of gray whales that never go up to the Arctic. They just feed around the Strait of Juan de Fuca and the offshore on the west side of Vancouver Island and the west side of outer coast of Washington. That's called the Pacific Feeding Group. These are not part of that. And then what you see over time is that we have more and more, but it's still relatively small. It's about a dozen or so whales that show up year after year after year. Now watch the gray whale feed here. So what it's doing, if you've never seen it, it's on its side, it's in a very shallow area, and you can see it's using its tail and its mouth, and you see the plume of dirt that starts to come up. It's basically digging through the dirt, putting it into its baleen, and then filtering out very small things like shrimp and stuff like that. So, spoiler alert here. Next one. Gray whales don't eat herring. I just wanted to cover some of the success stories as well. So let's talk about a whale that does, Minke whales. Now, what's interesting, even though this one is easy to tell, this whale has been hit by a propeller, and so even I could photo ID that whale, but there are people who are very good at photo IDing whales, and I want to give credit to Jared Towers. I always look at this when I was a kid and I'd say, what does that thing really look like? You know, it's the Loch Ness Monster. So Jared Towers got us this photo here. I think he just whistled it up, jumped out, got the picture. But these are the smallest of the baleen whales that we have in the world, actually. And there's even a miniature version in the Antarctic. Very small fins, dorsal fins set way back. And these animals are fascinating. You can photo ID them, and Jared did some work that shows that they tend to show up in the springtime, and then from photo ID, they'll migrate maybe 400 kilometers north, spend the summer, and then in the fall, they'll migrate back down again, and then they disappear in the wintertime. So it's a spring, summer, fall. And that's not because Jared and his crew were not out looking for animals in the wintertime. They were out there. They were doing their due diligence. And so what happens? These animals, what we think is they actually go into the tropics. Now, these are called ecological markers on these different minke whales. And you see the small white spots that are on the side there, and some of them up on the dorsal fin. These are called cookie cutter shark lesions. And these are important because what Jared and his group saw is that in the spring, some of these would be fresh. They would heal up, but they wouldn't get any more as the summer continued because cookie cutter sharks live in more tropical areas. And then the next year they would show up with new lesions again. So this is one of the ecological markers that's showing that these animals probably actually migrate to more tropical waters than here. Here's another one. This looks like this minke whale has a couple pieces of eelgrass stuck on its dorsal fin here, but these are actually parasites. They're external parasites. They're a type of a barnacle. Xenobalanus is what it's called. And again, like the cookie cutter sharks, these Xenobalanus only occur with animals that migrate into more tropical waters. So we think that these minke whales are spending their winter in more tropical waters. I think it's the darkness and the rain. And then they come back up here in the spring and spend the winter or the summer and the fall here, and then they go back down again. Now, minke whales are definitely feeders of herring, and they actually eat quite a variety. They'll eat creel, they'll eat herring, they'll eat sand lance, and some work, not done in the Salish Sea, but some work done in the Atlantic would show that they're very plastic, they have high plasticity. They can switch from one to the other. But if the herring are available, they're gonna go for the herring as above to the krill. And that makes sense, that's what I would eat too, right? And it's interesting here, you see in the back, these I think are some rhinoceros auklets in the back here. And there are two types of feeding that have been talked about in some different studies. Bird-associated foraging, so the birds are coming in, the rhinoceros auklets, the common murres are pushing up this ball of herring from the bottom. The gulls are plunge diving, they can only get in a foot or two. The minke whale sees this, comes up, eats the whole ball of herring, and then goes to another place. Usually happens when you're seeing these birds feeding, have your camera ready because it's usually like 30 seconds later when those minke whales start to pop up. And it's a really smart thing because they're kind of they're having help from other animals to do this. So here's another one. This one here, this one's called lunge feeding. And what you see, those are not herring. Kind of a little bit more snake-like. Those are sand lance that they'll also be eating in the Salish Sea. Lunge feeding takes a little bit more work. You have to find the fish. Usually you go to an area where these fish can be found consistently. And that's probably why minke whales, if they were around right now, would be coming to herring spawns, but I think it's a little bit early for them. Okay, and this is just a graph from Norway. Again, these animals have been studied in other areas more than they've been studied in the Salish Sea. But this is just an age class of herring. And imagine a good spawn in 1991, and then again in 1992. I don't know if I can use this thing or not. But what's happening is after the 1991 spawn, they're eating a juvenile 1-year class. Then the next year, they're eating a 2- and a 3-year class, then a 2, 3, and 4. And so basically, they're eating those animals that are sticking around after that. And then when there aren't herring, they're going to move on to something else like krill. So they're able to adapt. They're not totally dependent, but it's a good benefit for them. Okay, humpback whales are the next thing we want to talk about. Humpback whales used to be the most common large whale in the Salish Sea. Daniel alluded to that. In the 1900s, we started harvesting them. Last night, I think we talked about it as well. The last whaling station closed in 1965. And when I moved here in 2001, humpback whales were just not part of the ecology of this place. You just didn't see them. And then very slowly, they just kind of started showing up. And so, again, a picture, thanks to Brandon Cole, because I always want to know what they look like underwater, right? So very long pectoral fins, very long throat grooves. This is a 60,000-pound school bus-sized animal that's just jumping out of the water, shedding water like a Labrador retriever coming out of a pond there. Again, imagine these whales completely disappeared from the Salish Sea, and then they start coming back again. So And in the North Pacific, they've really increased. So almost up to about 20,000, and those are old data. We don't have new data on them right now. And if we looked at the Salish Sea, and we looked at sighting reports of humpbacks, the first one was sighted down in Puget Sound. I think it was about 1986, 87, 89. Then sightings started happening more and more again. And at that time, it was so rare. People actually published a paper on one sighting for that animal. And then they started coming back up, and sightings are biased by the number of people that are looking. But what you can really see is from around, the mid 2005, 2007, 2008, things really, really took off. And so what happened was we stopped hunting these animals, just like with the gray whales, and they start to return to old foraging sites. And then as competition starts to increase at those foraging sites, they're going to new areas to forage. And so then that's when they start coming into the Salish Sea. And so if there's food available for them at new sites, they're going to continue to come back to these new sites. And what we're seeing now is we even have animals that are coming back, not only coming back, but actually staying year round. And so it's nice to have this kind of success story of what's happening. And this growth here, here's another picture from John Kalambakidis' proceedings. All those gray dots, a little bit hard to see, and sorry we didn't get all the way up to Hornby. These are sightings, and so they're a little bit biased by whale watch operations or things like that. But this has been called the humpback comeback. And it's really a wonderful thing to have seen this sort of thing in the time in my life that I've been here. And so if these whales are, like the Minke whales, are migrating into this area, not many of them are staying, where are they coming from? Scientists use these things called distinct population segments. So if you look up where we are in the upper left-hand corner, those are the feeding areas in green. And then what you'll see is there are 3 DPSs that come. Most of them are coming from Hawaii and Mexico. And those populations, we as scientists are happy with those populations. They're doing well. They're growing. There's a third one, that's number 6 there in yellow. Those are animals that are moving up into this area from Central America. And that is still a population that's endangered or threatened. And so we, by having food for them in that critical foraging time in the summertime for them, could actually be responsible for helping to recover those populations that are still trying to recover in Central America. Now, interesting, another herring picture for you. This was also work done up in Alaska. Remember, we just don't quite have enough of these whales around here to get these kind of studies around here, but some modeling work that was done relatively recently up in Alaska that was looking primarily at what would happen if herring grew or herring collapsed. They felt that the humpback whales do have some top-down control of the herring, but they're not going to deplete it. It's a moderate top-down control. And that as the population would grow, they could outcompete other whales like the Minke whale that we just talked about. So remember that just like there are multiple different fish, the multiple different whales also can be in competition with each other. I did find there was a paper down in Antarctica that showed some trophic differences between Minke whales and humpback whales there, primarily with krill, and they had some separations on the places and the depths that they used. We don't know that here because they're still just coming back. We're just still trying to get those data on these animals as well. Now, what's a little concerning for me is that people are talking about humpback whales as a threat to herring recovery. And so it's kind of funny because you think that we grew up in a time like Daniel was talking about these shifting baselines where there weren't herring, or there weren't humpbacks, and then the humpbacks come back and they're taking something that we see as already decreasing. So we're spending a lot of time today talking about commercial fishing, but commercial fishers are also, what about us? What about the humpbacks? They're also taking them. Maybe we should stop the humpbacks. And so SeaDoc funded a study a couple years ago to start to look at herring recovery. What are the sorts of things that we need to be doing? When we wanted to really get into salmon recovery 30 years ago, we knew what to do. We knew how to deal with hatcheries and hydroelectric and habitat and harvest and things like that. We don't have all those answers for herring. So we put together a group of scientists that are working on some modeling exercises. And when you have a humpback population that's growing, these are large animals, 60,000 pound animals. And when you have a lot of them, then they start to say, hey, what is that top-down pressure and what can that be exerted? I'm not sure that's the right way that we should be thinking about the ecosystem. Okay, I want to talk about fin whales. Another animal that's come back thanks to the stopping of hunting. These, next to the blue whale, these are the second largest animal in the world here. And here's a picture from above that you can see from NOAA Fisheries. Just giant. I've seen one in the Salish Sea myself out near Smith Island, and it was late in the fall, and we went out there in the boat in a late afternoon, and I saw the biggest bird bait ball that I'd ever seen in my life. It was just as far as I could see from South Lopez almost out to Smith, and there was a fin whale that was out there eating them. So it was a great event for me. The only fin whale I'd seen before was this one. Okay, so just some numbers. Let's go to that one. This was the first fin whale I saw. I didn't have gray hair. It was maybe in 2001, and this was a ship strike animal. And so what we used to think originally is that a lot of these animals, this is another ship strike animals, these animals are feeding across transverse to shipping lanes. And as ships start to increase and as the population of fin whales grows, you get young animals that are getting hit by those boats. And this is a paper that Jared Towers did a couple years ago. So between 1999 and 2012, there were 11 sightings, 8 different fin whales based on photo ID. So relatively small numbers here in the Salish Sea. And over almost a 20-year period, there were about 11 whales, different whales that were struck by ship. And so we think as those whales are moving in to capitalize on herring and sand lance and smelt and things like that, they are at probably higher risk for ship strike. And definitely, as you can see here, they're known to eat herring, krill, amphipods, and things like that in other places. And I think that they are probably coming into these areas to eat them as well. We just don't have a lot of data on them because they're so rare in the Salish Sea. But there are a lot of big whales that are coming in. Okay, so let's talk about killer whales. That movie introduced the idea of the trophic relationship between herring and salmon and southern resident killer whales. I want to just diverge for a little bit and show you a video here from YouTube. This is in Norway. Okay, and so this is a herring ball, and some studies have shown that herring balls that are more round and tighter together are the ones that the killer whales use. Watch, this guy comes in, smacks him with his tail, boom, and then they just kind of come in and suck them down like French fries. Yeah, and even lazily, like they just eat one, and maybe I just eat half of that one, because I'm going to eat this one here, and so it's beautiful to watch this. And but what I want to remind you of is that when Norwegians were having trouble with their herring fishery, this is all the way back in 1969, they actually called killer whales. And they called, between 1969 and 1980, called 700 killer whales in an attempt to reduce pressure on the herring fishery, right? This is this linear, simplistic thinking of, we have a herring problem, killer whales eat a lot of herring, let's kill the killer whales. Guess what? No metrics were used. The herring population never recovered, and it took them a decade to say, geez, we've killed 700, it doesn't make a difference. Maybe we should stop killing them and do something else. And so we have to be careful about that thinking and about where that thinking gets us, but more importantly, where that thinking doesn't get us. It seems, time after time, it seems to be the simple solution. Why should we stop fishing? We can just get rid of humpback whales or that sort of a thing. Let's talk about the killer whales that we do have in this area. We actually have 3 ecotypes. We have the transients, mammal eaters, also called the Biggs, after Michael Biggs, the fish eaters, the northern and southern residents, and there's a third type closely related to the fish eaters that specialize in sharks that are offshore, and they will come in to eat salmon in this area. And none of these eat herrings. Spoiler alert there. But the relationship is still there. So here you have a transient that's about to eat this seal. And one of the things that we have to remember is that the pinniped populations have bounced back. Those are not all rocks. Those are all sea lions, stellar sea lions and California sea lions. So we're seeing these populations at levels where nobody alive has ever seen these animals at a level. And it does start to make people nervous, primarily not because of herring, but because of salmon, because of Chinook salmon recovery, and because of the shift in baseline. So Elizabeth Ashley made this nice little food web for me, pretty simplistic. But, so what happens when the herring disappear? Well, that modeling that was done up in Alaska shows that when herring disappear, not resident killer whales, but the transient killer whales are likely to be affected by that. Same thing can happen now if we talk about culling of seals or sea lions. Same thing is going to happen, that we're going to have potentially and probably very likely have problems with the transient whale population. So I was on the governor's killer whale task force for a couple of years, and a lot of people wanted to kill a lot of pinnipeds because of data and concerns about salmon. And they do eat a lot of salmon, but I thought, are we going to be here in 10 more years than doing a transient killer whale recovery program because we've been culling the pinnipeds? And so it's that simplistic thinking that I think we need to think about. Okay, so southern resident killer whales. That's okay, you can go forward on, that's great. As most of you probably are aware of, there are three major factors that we're worried about: contaminants, prey availability, and vessel disturbance. And we're just starting to learn how to look at interactions of things like this. And there was some nice work, modeling work done called population viability analysis, where they looked at all of these different things. And what they found is out of these three, the bigger two were the prey availability and the vessel disturbance, and primarily the vessel noise. And so the transient killer whales are one more level up on the food chain than the resident killer whales. So they are eating animals that are eating salmon. So they actually have higher contaminant levels, but those populations are doing very well. The reason is that the southern residents don't have enough prey. And when you don't have enough prey, all those persistent organic pollutants are stored in your fat, in your subcutaneous tissue. So you go through periods of intermittent starvation, intermittent fasting, then you metabolize those, and then those persistent organic pollutants we think can suppress the immune system. So why vessel disturbance? Why vessel noise? Well, remember that these animals are acoustic. They communicate with each other through sound. They find their fish through sound. They herd them. And so when you increase the amount of noise, you actually reduce their ability to find fish that are already at low levels, okay? And so imagine, and there have been some great papers that have actually calculated the number of foraging days that we have removed for southern resident killer whales to be finding salmon, just because the amount of noise that we have in the water from boats. And so a lot of the efforts to recover southern residents are not just focused on recovering Chinook salmon, but also slowing boats down and keeping boats further off. Those are the two things we know we can do to reduce noise. It's to slow a boat down and to give it more distance between the boat and the whales. Okay, so let's go about prey. You're going to hear a great talk after this. Vanessa's going to talk all about Chinook and other salmon and what they eat. But southern residents are really primary Chinook eaters. They will eat some other salmon as well, and they'll eat some other fish, but primarily Chinook. So when you look at this picture, what's kind of missing from this is what's in front of that Chinook salmon. And this is an old paper, but I really like this one because they looked from California all the way up to Alaska. And down in California, Chinook are eating forage fish like young of the year rockfish, but as they start to get up to Washington and into BC, they really depend on surf smelt or on sand lance and Pacific herring. Okay, so I had Lizzie put this one together for us. And so the idea that has been talked about multiple times today and in some of the movies and some of the speakers is that if we're really trying to recover salmon, and if we're really trying to recover southern resident killer whales, why aren't we doing a better job of really trying to recover herring if that's really important for those animals? And we talk about the money that's involved in the herring fishery. What we find at SeaDoc a lot of times is we don't have the opposite. So we funded Earth Economics a couple years ago at the time when the governor's task force was created to look at the value of whale watching, and primarily killer whale watching, in San Juan County and the adjacent Island County area. So this doesn't even include BC. Apparently the economic monitors are a little bit different in Washington and BC, so we only had to do the Washington side, but $216 million worth of activity annually. And there's hundreds of jobs that are created, and I forget the actual number, but the report's free. It's on our website. You can actually go back and see the millions of dollars of taxes that are actually coming into Washington State for that as well. So even when people have economic arguments about stopping a fishery, there are also economic arguments about stopping a fishery, so that maybe you're going to lose some fishing jobs, but maybe you're going to gain some watchable wildlife jobs. And what we found in Washington State is that watchable wildlife is a $2 billion industry. And these are numbers that are back as far as 2008. We haven't done these numbers again. $2 billion a year industry, 26 million jobs. That's second probably only to Amazon and Boeing and Microsoft in Washington State. And what it does, watchable wildlife takes money from urban centers like Seattle and usually dual income earners who don't have any kids at home, and then moves that money into rural economies like where I live, Orca Island, or probably the same for Hornby Island, brings money into rural economies. And so it's a way to decentralize the wealth that's in an area. And so watchable wildlife, but the problem with watchable wildlife is that it's hard to see. You can go to a Seahawks game, or you can go to a Canucks game, and even me with my limited math skills, I can say, okay, how much the average ticket cost, how many people are here, how many beers are they drinking? It's higher in Canada than the US. You can do some quick calculations, right? But what happens with watchable wildlife? These people are out there, they're bird watching, they have binoculars, they're very quiet. They're not, you don't see them going out in mass and numbers and things. So it's very hard for legislatures to wrap their hands around the number of people that spend a lot of money on a lot of travel time and buying a lot of materials to do this sort of thing with watchable wildlife. And so I think it's something that we all need to be considering as well when we go up. Okay, I'm going to talk about something a little bit different complexity. You're probably all wondering what that is, but it says river lamprey down there in the corner. What I want you to think about now, we've talked about whales competing with other whales. We've talked about sea lions competing with people for things like salmon and things like herring. We've talked about competing economics between fishing communities and watchable wildlife. Let's talk about just an intro to what can happen with the ecosystem. So lamprey are super ugly. Nobody wears like I love lamprey shirts. It's not like I'm in the Slow Loris Club or whatever. People don't get tattoos of them. Most people don't. There are several different types of lamprey that we have in there. They're kind of a primitive fish, and they're super cool predators. And they come down, some of them stay in the river, some of them are anadromous, so they come into the ocean and they go back, and they're really big predators. And so what I want you to think about, and this is also another old study, but I'm going to show you this graph here. This is Dick Beamish's work from a few years back. So this is just looking at a couple years in one river system of how much just the river lamprey, not the Pacific lamprey, we're eating. And so if you're eating 20 million pounds of Chinook, 15 million of chum, and you're eating 156 million of herring at that time, so what happens then if herring disappear? What are the river lamprey going to eat more of? Well, you go to the salad bar, you eat what's on the salad bar. You're not like calling stuff in from the back, right? And so they're going to eat what is available. And so when one species is less available than another species, we eat more of it. And I think some of that is what's going on with the salmon too. We have major releases of hatchery salmon. That's what those seals are going to be eating because that's what's coming out of the rivers is the hatchery salmon. So there's a complexity. The bigger the menu for these animals, then the more things they're going to eat, and then the more escapement that you have. So by having a gazelle with a zebra with another gazelle type, the lion's not going to take one of each, right? So you have a better ability to actually survive what's going on. And so think about that. We'll keep moving from there. What if we remove harbor seals? Well, harbor seals eat over 63 different species of fish and invertebrates like squid, but one of those are river lamprey and lamprey. And so if you think that you're going to benefit herring or you think you're going to benefit salmon by pulling out a harbor seal, what you actually need to do to check that out is you actually need to do some ecosystem modeling to see how many lamprey are you going to leave in the system, how many other predators are you going to leave in the system that could be eating the things that the harbor seal is eating, right? So if your harbor seal is taking out lamprey and you leave less predators on lamprey, then they're going to eat more of the other fish that are out there. And so that's just the sort of thing that I want you to be thinking about when you think about herring, and you think about different arguments that people have for culling or bringing back whales, stuff like that. So this is one of the papers I was reading to prepare this talk was some work done in the Gulf of Maine. And the author said, we suggest fisheries management must move beyond a single species approach to one that includes a formal consideration of trophic relationships. We've been talking about that for a long, long time. And we're probably doing better at that. But we as people who enjoy these things also need to be thinking about how these things interrelate from more of an ecosystem level than just a very simple predator-prey level as well. So I think I got us back on time. Okay? And thanks all.